And thank you everyone for coming, and thank you Joy and staff at DuPage County for inviting us for today's workshop. And we are really all surprised to see all of you here. Actually, we have like 130 people registered, and I noticed there are some walk-ins too, so maybe we are more than 130. So thank you all for coming. So today's presentation, before I forget, it will, typically we upload our PDFs on our website. So somehow if you, lose your handout or need more copies, you would be able to download from our website later. And we plan to have like a 3-hour-ish workshop, so it will, probably end near like at 12, and we plan to have a break in between, maybe sometime between 10:15 to 10:30. And during the presentation, if you have any questions, just raise your hand. You can stop us anytime, or you can just wait until the end and you can ask the question then too. Okay? Alright, so my name is Sumi Han, and I'm from Smart Energy Design Assistance Center, CDAC, at the University of Illinois. How many of you know of us, CDAC? Yay! Great! And there, my colleague Ryan is taking some pictures, and so we both work at CDAC. So just wanted to introduce you who don't know who we are. So we are the university organization, and we also actually a private and public partnership. So it's a very unique organization, and we've been working with the state for more than 15 years, helping mostly, public sector energy efficiency projects. So that's how we have a good relationship with many public sector clients throughout Illinois. And in addition to our traditional energy efficiency project, we recently started working with State Energy Office. I don't know if you guys are aware, but the State Energy Office used to be under DCEO, Department of Commerce and Economic Opportunity, and that has changed. And now State Energy Office for Illinois is under Illinois EPA. And we are working with EPA for training the energy code throughout Illinois. So so this workshop is a part of our energy code training program. So a little bit about our energy code training program. It's not just workshops, but it is more than that. So we have a technical support. We have 1-800 number, and we have email address, energycode@cdac.org. So we provide technical support to code officials, architects, and engineers, and sometimes homeowners too. So if you have any code-related question, you could contact us through phone or email, but email is always the best because code questions could be a little confusing and hairy, and sometimes we cannot give you the answer right over the phone. So email would be the best way to get us. And also we have a website, online resource center, cdac.org energy code, and it has lots of information about this state, energy code and other resources. And we provide workshops like today's, and we have webinars. So we had a couple of webinars so far, and we just had our first webinar this program year for the residential 2018 and IRC, and our second webinar will be on January 16th. It's going to be on commercial envelope and IBC. So stay tuned for our webinars too. And also we have an online on-demand training modules. These are designed for just hour or an hour and a half long online modules. So if you don't have time to come to the in-person workshop, or you cannot make to the webinar schedule, you can always log in at your convenience, and you can stop and come back and finish it. So that's the, summary of our whole training program. So this is just a screenshot of our website. So if you go to our website and top right, there's Energy Code Training tab. If you hit that, then you will have lots of sub-menus here. So this is the look of our online training modules. So far we have developed 4 modules. 1 for residential, 2nd commercial envelope, commercial lighting, commercial HVAC. So this is how it looks for the online modules. So there are some menus that you can navigate through, and we have some code language. These are kind of basic code material, so it doesn't cover all the details. But if you are not familiar with Energy Code and if you want to get to know a little bit more about it, this is a good starting point. And at the end of each module, we have a quiz. We have like 10 questions for each module, and if you score more than 70%, you will pass and you will get a certification. But don't worry, if you don't, you have infinite chance of retaking, so you can come back and take it again until you get more than 70%. And we also provide certifications, so those could be used as your continuing education credit. So the way that we organize this presentation is that we're going to go over some basics and why Energy Code is important and what are the benefits of Energy Code before we actually talk about each requirement. So first half is more general view, and then we will go over more specific things later. So why are we all here to talk about Energy Code? Why is it so important? So buildings use a lot of energy and create a lot of emissions. So here's the first quiz. Commercial and residential building in the US consumes how much of the nation's total primary energy? What is your guess?
35.
35%. 60%. 80%. 90%. Well, actually, it's about 70%. So it's a lot. So other 30% is for industry. The buildings actually consume a lot. So that's why building energy code is important. Second question. So building consumes, in terms of electricity in the US, how much of electricity building consumes? 72%. Somebody did the homework. Okay. Yes, it's about 70%. So in terms of if we're looking at the electricity alone, it's a lot. So building actually, consumes 70% of the U.S. electricity, and that's why we are interested in Energy Code, and that's why all we are here, I hope. And then for the total CO2 emission that the building actually contribute is how much. So not only the consumption, but we actually by using the energy we produce some CO2. So how much of CO2 bad thing that we are producing from the buildings? 35, good guess. 40%. So it's really substantial percentage of the consumption and emission. So this is just a quick graph. So this one shows commercial 35% and residential 37%. So total commercial and residential, it's about 70%. So these other graphs are more detailed view, but I'm not going to go over that. But just I want to emphasize one more time, it is a lot that building consumes. Then what are the benefits of Energy Code? So if you reduce energy consumption, so actually if you comply with energy code, you reduce energy consumption by 3.5 quadrillion. I think that's like 10 to the 15th, a lot, BTU per year by 2030. And then approximately 3% of the national CO2 emission, we could reduce by 3%. It doesn't sound like a lot, but still, And actually, in terms of dollar amount, the building owners would be able to save, $30 billion by 2030 if all the buildings comply with the current energy code. So that's about, just why we care and what are the benefits. So now let's talk about Illinois Energy Conservation Code. So today we're going to talk about 2018 IECC, but that's not exactly the Illinois Energy Conservation Code. Illinois adopts IECC, but we have our own flavor to add to it. We have Illinois Amendment. And CDB is the one who kind of, is in charge of that process and adopting it and, reviewing the proposal as well as advisory councils. So this is a website for CDB, and it talks about what is the Illinois Energy Conservation Code and who needs to be complied with. And then one change in the 2018 cycle, which is, this new code will be effective. We anticipated that it will be effective in March 2019. So right now, all the amendment proposals were reviewed and passed through the advisory council. And a couple of weeks ago, the Secretary of State approved. So if nothing, extraordinary happens, if it goes as we planned, it will be, effective in March 2019. So one change in that, new amendment is that 2015, the current code, state-funded facility need to comply with ASHRAE 90.1, not the IECC, but it's going to change in this new code cycle. They decide, that's too much, why not state buildings also comply with IECC? You can still do ASHRAE 90.1 as one compliance path under IECC, but the state facilities are not mandated to do 90.1 anymore. So I think that's a big change if you are, dealing with lots of state-funded facilities. So as I said, March 2019 is a big date that we are going to all, have to comply and enforce this new code. So I think I briefly already talked about this. This is this process. So if I can backtrack a little bit, so for this code cycle, the amendment proposal reviews are all done. So it's all reviewed and done, and move forward to the next step. But I want to just share this slide with you for the next code cycle. So if you have any ideas, if you have any suggestion, anybody could submit the proposal to advisory council for their review. So this is a form for the public code change proposal form. So if there are any, code section that you think in Illinois doesn't make sense, or if you think that you have a better idea, that this is a form. It's simply you just state your contact information and what are the sections that you want to change and why you want to change it and what is the cost impact. So there's always push and pull in between, like a green building, industry people and like a industry, just construction, industry people who want to always kind of want to have a less stringent code, and there are also, other side who want to have a more stringent code. There's always push and pull. So I think Illinois is having a good job not to be dragged into any one extreme. But if you have any idea, this is a form and you can submit to the advisory council. So one example on Illinois amendment. This is a snapshot from the 2015 IECC amendment. This is just to show you what kind of amendment that Illinois has. So this is a residential provision for the insulation. So according to 2015 IECC, climate zone 4 and 5, for the windows, the solar heat gain coefficient was 0.40, but then they thought, oh well, it's all in Illinois, so it'll be confusing to contractors if the southern Illinois and northern Illinois had different numbers, so let's just make it to the same. So that's one motivation for them to go ahead and change it. And then this one, same thing, Zone 4 and Zone 5 used to have a different, according to 2015 IECC, it has a different requirement for the R value, and they say, oh, well, that will be not convenient for people who need to actually, have a project across those climate zone maps. So those are, small changes. And sometimes Illinois amendment has changes in definition, especially for Chicago. So in terms of residential building, according to IECC, it's 3 stories or less. But then in Chicago, it's 4 stories or less. So those are the types of amendment or changes in Illinois. So I don't know how many of you are, working in the city limits, city of Chicago. Do you have any projects that it's in the city limits, or do you? Yeah, some. So this is Chicago has their own energy code, or sometimes we call it Chicago Amendment. So if you are in Illinois, then not only you need to look at the IECC book, but you need to look at the Illinois Amendment. But if your project is in the limit inside the city of Chicago, not only the Illinois Amendment, but also you need to look at the Chicago Amendment or Chicago Energy Code. So they have a slightly different, requirements than Illinois Amendment or IECC. But recently they have changed their energy code compliance process. Oh, and I also want to mention that here, if you go to Chicago Building Department, they list all the references here, and then free technical assistance for design professional, and I don't know if you can read it, but this is us, Illinois Smart Energy Design Assistance Center, CDAC. These services, funded by the Illinois EPA Office of Energy, and it's free for everybody in Illinois. So Chicago Amendment or Chicago Energy Code, the language changes in the code official, they say City of Chicago Department of Building or Building Commissioner. And then in terms of historic building, they have their own, flavor of things, Chicago Landmark, or things that are, coded in the Chicago Historic Resource Service and things like that. And then one thing that I want to mention, this is very unique in Chicago Energy Code, is that urban heat island provision. So this provision is not in the IECC, but Chicago added their own definition and the requirements. So if your project is in the Chicago, then you need to comply with the urban heat island provision section in the Chicago Energy Code. So one of the biggest change, I think, in Chicago Building Energy Code is that REP. How many of you are familiar with REP, Registered Energy Professional? Great. So I don't know if it's a good news or bad news. It's not, no longer, they don't use it anymore, and you don't need to keep your status as REP anymore to submit the permit document to the City of Chicago. So before, they said something like this document needs to be attached to the permit document signed by REP. REP is just like a registered architect or engineer who went through at least one energy code training. But now they say they're not going to maintain that list. So they said any architect or any licensed architect or engineers could sign it. So you don't need to be qualified as REP anymore. So this is old form, and this is a new form for the City of Chicago. So I actually personally like this one much better. So we have that same kind of, the information here, sign and contact information. But what I want to emphasize is the bottom half. They have a compliance method, and you actually need to check what compliance method you are following for this particular project. So if I zoom in, the bottom half, this is for the commercial. So there are several checkboxes that you need to check. And first one, ComCheck, it says recommended. I think probably like a 70% of project you guys do ComCheck for code compliance. So that's that. And then you can do prescriptive path, which they divided into simple and complex HVAC system. And then their total building performance methods. So this is a performance method like energy model and stuff. And then you could do ASHRAE 90.1 because ASHRAE 90.1 is actually one compliance path under IECC commercial provisions. So they listed here as a one compliance path you could do, ASHRAE 90.1 prescriptive path. And then second one, ASHRAE 90.1 energy cost budget, that's performance-based. And then the last one, interestingly, it says performance rating method. It's Appendix G. So I don't know how many of you are familiar with Appendix G in ASHRAE 90.1. So it used to be not a energy code compliance path. People use this ASHRAE 90.1 Appendix G as for lead project or other high performance program, but not for energy code compliance. So what happened is, even though you have Appendix G energy model, you need to have a separate document for code compliance. So now City of Chicago is saying that Appendix G is actually a compliance path. And this actually happens in ASHRAE 90.1 2016. So technically in Illinois it'll be effective in March of 2019, but somehow Chicago, I think, just went ahead, while they're updating their program and form, they kind of included this. So that is listed here, so I believe it is already kind of effective in the City of Chicago. If you are if you have lead project and doing Appendix G, then it seems like you don't need to have another energy compliance documentation. So the sister document of that is a residential. Just that this is the bottom part of that document in the Chicago Building Department. So residential similar. So compliance path, you need to pick which compliance path you are complying with. First one is red check and prescriptive and simulated performance method and energy rating index. So this one is a HERS index, right? So basically, in a nutshell, you could either do prescriptive or performance, but there are subcategories under prescriptive and under performance path. And this is actually very useful, so they added the following mandatory energy conservation requirements apply to all residential projects. So these are IECC residential provisions and mandatory provisions. So whatever compliance path you are picking and choosing, you need to comply with all these requirements. So this is a great checklist for you because, code books, sometimes you kind of get lost in the middle of all the details and stuff. But this is just a quick and easy checklist. So open this up and see if your project is comply with all this, separate requirements and sections. So I highly recommend that you kind of print this out and have it in your, wall, and that for easy compliance, checklist for your residential project. Even though you're not in Chicago, because it applies to all IECC code. So that's Illinois and Chicago amendments and energy code. So what about 2018 IECC? That's the model code, or sometimes people call it standard code. So ICC is one of the code that is under ICC branch. They have other building codes related to ICC, like IBC, IRC, and IMC, many of those. So 2018 ICC, because this is going to be the base code for the Illinois, which will be effective in March 2019. So before we jump into each section, I just want to briefly talk about the compliance path. So commercial projects, commercial provisions in IECC 2018, you have basically 3 options or compliance paths. One is ASHRAE 19.1 2016. So if you open up the book, and you can close the book and open up another ASHRAE 90.1 2016 and follow that. And that will be comply with 2018 IECC, and meaning that Illinois Energy Code also. And second compliance path is prescriptive. So prescriptive is like a checklist kind of thing, right? So you do this, check, 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 check. Right? So there are, provisions that you need to comply with. Envelope, mechanical, and service water heating and lighting. And this is important, on top of those, you need to pick at least one of the additional efficiency package. So those additional efficiency packages are, first, more efficient, HVAC equipment, and reduce lighting power, or enhanced lighting controls, or on-site, renewable energy, or dedicated outdoor air system, and high efficiency service water heating. And these 2 are new to 2018. So on top of these 3, 4, 5, 6, they added 2 more as an additional efficiency package that you could pick. One is enhanced envelope performance. The other one is reduced air infiltration. So in a big scheme of things, if you are going through the the prescriptive path, you need to comply with all of these, and you need to pick at least one of these. So that's a compliance with IECC 2018 commercial provision in prescriptive path. And the third option that you have is performance path. So you need to have comply with all these, mandatory provisions and any, building performance related provisions. And bottom line, that you need to prove that your design is at least, or needs to be less than 85% of the base, model. So you need to save more than 15% in terms of energy performance. Then you will be qualified for the performance path, compliance path. So that's the big picture.
Question,
Yes.
if you're utilizing ComCheck or ResCheck, would that apply to one of these?
Okay, so this is a commercial provision, so I will talk about ComCheck. So ComCheck is kind of hybrid. I think it's probably easy to kind of understand. ComCheck is a prescriptive path, but ComCheck allows you to trade off. So under the prescriptive path, you could do really straightforward prescriptive path, but if you are using ComCheck, it allows you to trade off some, R values between walls and ceilings. So if you're doing ComCheck, you don't need to worry about that much about this or this.
Can I make a comment too?
Sure.
Can you drop back one slide? When you're doing the performance package, that 15% savings is represented in the C406, which you don't have to follow when you're doing the performance package. So the savings achieved through C406 are thought to be roughly equivalent to the 85% of the standard design. So just so that you know, you don't have to do that if you're doing the performance because you're taking the 50% cut.
Right, so everybody heard this comment, right? Yeah. So that was a commercial provision, and this is the residential compliance path. So roughly, people have different way of kind of categorizing, but this is from DOE slide, and the way they organize the compliance path for the residential provision, prescriptive and simulated performance and energy rating index. So these two are both a performance path. So if I can draw one more category over here, it'll be performance. So under prescriptive, no trade-off, as I said, just straightforward prescriptive. And then trade-off, this is typically done by ResCheck. So that's the under prescriptive trade-off. And simulated performance, you need to, comply with R405. And then the ERI or HERS rating, that's R406 requirement. So, the IECC book is divided, between commercial provision and residential provision. So what are those? When do you need to open up the commercial provision section, or when do you need to open up the residential provision? It sounds very straightforward. Yeah, residential buildings you open up residential provision. The commercial building, commercial provision. But sometimes it's not that straightforward. So, we get questions through our technical support email or, phone. Sometimes they don't, mention which project it is, and by just description we get a little confused. So anyway, I just want to mention that probably it's a good idea to go over briefly on what is commercial building and what is residential building in terms of energy code. So residential buildings, they are detached one family or two family dwellings. If it is, then it's residential building, and you need to open up the residential provisions of the code book. And any building 3 stories or less that contains multiple dwelling units, or 4 or less in Chicago. So that's residential buildings. What are commercial buildings? Everything else. If it's not residential, so code actually in the definition, if you look at it, if it's not residential building, it's commercial building. So that's actually, quick and easy, simple definition for commercial. So examples of the residential buildings are these, So quick quiz. 5-story mixed-use building with 2 stories of retail and 3 stories of apartments in Chicago. Is this a residential building or a commercial building? commercial building. Everybody thinks so? Because, yeah, four less, and it contains the dwelling units there. And the second one, 3-story mixed use with 1-story retail and 2-story apartment in Bloomington. Is this commercial building or residential building?
Well, not commercial.
Oh, both. So why do you think it's both?
You've got 3 stories, you've got apartments in 2, and you've got 1 floor commercial.
So it's actually, by definition, it's a residential building, but for the residential occupancy, we'll go through the residential provision. But in terms of just a building, it's a residential building. But the commercial space will follow the commercial provision, but a residential space will follow the residential, provision. But as a building itself, it's a mixed-use residential building. So third one, 5-story single-family home. Is this residential building or a commercial building? Commercial building? Residential building. Yes, because, it doesn't matter how many stories. If it's a single-family home, it's a residential building. But you would rarely see the 5-story single-family home. And then 3-story hotel, residential building or commercial building? Commercial building, because it's not dwelling unit, it's sleeping unit. So this is a graph to show a history of model code. So this graph, x-axis is the year. It started with 1975, and this is 2018. And then y-axis is a 0 to 100, 0 to 100 for the residential energy code and commercial energy code. So this is based on the data from DOE. So DOE by statute is required to publish the result of their analysis. So what is the energy consumption of the building that is comply with certain energy code, and what about the next version of code? What about the next one? So we make sure that we actually have, write the energy code that actually consumes less energy than previous version of the energy code. So the reference point is 1975 code. So this is a normalized energy consumption. So let's say it's 100. So how far did we drop? So in 1986, it dropped to 90, and then 88, 87, and then there's a big jump here around 2009 from 84 to 72. So there are some big jumps here in the residential, but recently, if you look at 2015 ICC, and then 2018 ICC, actually virtually no change in terms of energy efficiency. So that's a little sad story. In the commercial side, similar, but a little better between 2015 and 2018, 52 to 48. So if you think that, by 2030, so this is 2018, so 2030 will be somewhere here. We want to do net zero. So we want to really, have a really, really steep curve, which looks a little, disappointing, and we don't know if we could make it. But I think because this energy code is just a minimum requirement, so at least if we comply and enforce this minimum requirement, our hope is that we will be in better place than before. But overall, it's not that promising, just based on the data. So we could do better, and there are still rooms to improve, I guess. It's getting harder and harder, but... So for the 2018 IECC, I know some of you guys asked if you will get the code book today. Well, yes and no. And the good news I will say first. So if you go to our website, and there's a link to 2018 ICC, or you could just click this link. And there's a web version of 2018 ICC available to everybody, so it doesn't require a sign-in or anything. So the great thing about this web version is that if you have, things that you want to know, you can type in as a key, search word, then it will highlight that section, and then it will show you. So it's really convenient because physical book doesn't do it. Sometimes you kind of need to remember which section or need to know the correct section to look at. So I highly recommend that you use this resource. So that's the good news part. In terms of physical book, so our current state energy office doesn't have a healthy budget for the energy code training program. I hope you could understand. But we want to do, good for the public. So we have a little bit of budget for the code books for only code officials in the municipality. So during the break, if you are a code official and need a 2018 ICC book, come here to the station and sign in, and we have books for you. But sorry, if you're not a code official, web version is what we could offer. So that's it. So during the break, if you are code officials and need paper copy of 2018 ICC book, come see me at the side table. So a few of the highlights in terms of commercial provisions of the 2018 ICC. So as we look at that graph, no significant energy improvement. The DOE's estimate is probably 2 to 5% better than 2015. That means there's no significant change in 2018, but there are some changes that you guys want to remember. And then mechanical section, C403, what they did is basically there are some, efficiency improvements and stuff, but they kind of reorganize the whole section. So if you remember old section number in 2015, probably it has changed. So their intention is to make it easier for us to find the requirement for the similar or the same type of system or equipment. And then I think we already talked about it. There are 2 additional efficiency package options. One is the enhanced envelope, and the other one is reduced air infiltration. These are the ones that you would need to pick if you are going through the prescriptive path. And there are 6 other efficiency packages that you could pick in addition to these new 2 options. And there are some admin and definition sections, some language, they try to make it, more clear. And one big change, I think, in terms of control, lighting control and HVAC control, before in 2015, the language was something needs to be capable of something, right? So, great. But, it could be interpreted as a loophole. Some control could be capable of something, but it's a different story than is it actually doing it or programming it to do it. So they try to kind of, minimize that, loophole or confusion by changing the language from be capable of to be configured, meaning that now the controls need to be capable of and also need to be programmed as to whatever they're supposed to do. And then there's a new appendix in 2018 commercial section. There's appendix CA, it's called Solar Ready Zone. So this is a new addition to the commercial provisions. So residential provision, 2015 actually had this. So it's not new to residential provision, but it's new to commercial provision to have this appendix. So this is not a part of requirement, but is appendix. So if any municipalities or any project thinking about solar project down the road, not right now necessarily, but something in the future, it actually, I think, provides you a good guideline. So this, if you work for a municipality and if you have lots of solar project coming in, then you might want to kind of, pick this section like, hey, there's actually in the Energy Code appendix, this one gives some guidance on future solar projects. So not a requirement, but it's a reference for you to use. And another few highlights. So ASHRAE 90.1 2016, as I mentioned, is a one compliance path under a commercial provision of 2018 IECC. So we're going to spend just a few, minutes to talk about it. So one thing is climate zone map. So between 2013 and 2016, ASHRAE 90.1, they updated their climate zone map. So that means in Illinois, there are 6 counties that has changed their climate zone from 5A to 4A. So what it means is if you have projects in these 6 counties, and if you decided to go for 90.1 compliance path, then you gotta make sure that you now have an updated climate zone map requirements for the all R value and U factors and stuff like that. But also one thing to remember is IECC did not change their climate zone. So what could happen is in these 6 counties, depending on if you're picking just IECC prescriptive or performance or ASHRAE, you might have different climate zone. So no change in IECC, but some changes in ASHRAE 90.1. And then we talked about this when we talked about the Chicago. So Appendix G, the performance-based compliance path, it was not a compliance path, code compliance path, but now it is under 90.1 2016. So I think this is a good news for many architects or engineers who are doing lots of LEED projects. So in terms of admin or definition changes in commercial provisions, so we want to just highlight the building documentation and closeout submittal requirement. So record document, compliance document should be provided to the owner within 90 days of certificate of occupancy. Also, training should be provided. So it is written in the code and it's a requirement. So it needs to be complied and it needs to be enforced. But we hear that from code officials, it's challenging to enforce this requirement because once the certificate of occupancy is issued, it's really, there's no way for them to go back and check if these are done right. So this is for the architects and engineers. Make sure that you do it even though it's difficult for code officials to enforce it. And then C1051, the inspection, it used to say the construction work shall remain accessible and exposed, and now they say, visual and accessible. It's the same thing, but slightly different. They, again, try to make it clear and try to make it more, specific, so there's no way around it. And thermal envelope inspection. So now, it used to call it framing and roughing inspection. Now it's called thermal envelope inspection. So continuous insulation and things like that needs to be complied, and your code officials will inspect and enforce like that, not just framing and roughen as a thermal envelope as a whole. And then some other definition, air barrier, same definition, but they added, again, to make sure that nobody misunderstands. It's the air barrier should be in continuous manner. And then alteration. It used to say, project that is, non-repair, addition or, things like that. And then it says that requires a permit. And now, 2018, actually they struck out that language requires a permit. So our interpretation is that even though there's no permit, you should comply with the energy code. But then in terms of enforcement, probably it'll be difficult because there's no permit. But energy code said that alteration should be complied with the energy code. And they struck out the language that says that requires permit. And then approved. Approved used to say approved by code official as a result of tests and investigation. And now they just simply say approved means acceptable to the code official. So that means, I think, code official has now more authority and responsibility. So if there are, areas that kind of technically infeasible and things like that, now code official, if he or she says it's fine, then I guess it is fine. It's approved by your code official. So code official has more say to on what is approved and what is not approved, even though it is not going through any tests or investigation, I guess. Some changes, the admin type of changes in residential section. So same, the air barrier and alteration approved. And one thing that is different in commercial, it doesn't have this definition, but in residential it does. Air impermeable insulation. Then an insulation, that means the definition of this is an insulation that functions as an air barrier material. So it is added to the definition in the residential provision. So I think now it's time. What time is it? So 10 to, we will have another 20 minutes and then have a break. And from here, we will go over like section by section requirement, more detailed code changes that you need to know. And Ryan is going to take over from here. Thank you.
All right. So talking about our commercial side of the house, I think probably, I don't know, how many of you, commercial tends to be the majority of what you run into? A fair bit. How many residential is the majority? A little less, but not bad. Okay, so kind of evenly split. So looking at it, and this comes into play, we get this constantly. This is definitely a frequently asked question, is as far as space conditioning, what is it, can we qualify, do I have to comply with the thermal envelope? And this is one provision that the code provides for, is this low energy building. And the code provides this definition here. For some perspective, the passive house standard is 3.2 BTUs per hour per square foot. So this is kind of getting into that passive house area, saying if you're doing that, you don't really need to deal, we're not going to focus too much on the building envelope, but in order to comply and make a comfortable building, you probably already focused on the thermal envelope, so I didn't have to go through that again in too much detail. So here we talk about, what do you deal with for a building that has no heating or cooling system. This is one of those that may qualify as a low energy building. However, normally where we'll get this question is in a building where someone is building the building and someone else is going to build it out and fill it in when the occupant arrives. And so we note that while you may qualify as a low energy building now, and so you don't have to follow the thermal envelope provisions, if someone goes to build this out and they add heating or air conditioning and it no longer qualifies, you may have a very expensive retrofit to retrofit that envelope to qualify now. So, we are definitely supporters of compliance with the energy code, and we encourage people to comply as early and as soon as possible, because it tends to be less expensive that way for them. Plus you get a better building. Net zero building, this is another question we had gotten, was, do net zero buildings have to comply with the code? Again, could be a low energy building. This one's a little strange in that if you're doing a net zero building, why are you utterly concerned about having to comply with the energy code? Because you're probably building a good building. So compliance should be nothing too heavy for it. Heated slab, this is something that has moved from the 2015 to the 2018. Now early on you had seen where there were several large jumps in the energy code performance, and we had heard from several municipalities out there that there is some consideration and some desire to consider only updating these codes every 6 years instead of every 3. That makes a lot of sense, particularly earlier when we saw those large jumps in performance, because the codes were changing rather dramatically from one cycle to the next. Now, the code is much more just tweaking around the edges and making some minor improvements. And this is one where looking at continuous insulation for heated slabs. It used to require this additional R5 in this perimeter insulation. In the 2018 code, they've now moved it so the R5 is under the entire slab. Again, we're trying to provide that thermal break between the ground and the heated surface. For daylit zones, they've now kind of broken this apart a little better in that it's now top-lit and then side-lit zones. So top-lit being from skylights, rooftop monitors, and things like that. And providing guidance as far as how large that zone is. And these zones need to be labeled and marked on the prints. This is one example of how that might occur on the prints. This is a school building that has some perimeter windows. There weren't any skylights or anything, but you can see where we've shaded from the window in, and then the width of the window plus approximately 2 feet. And so these diagrams are actually directly in the code book, and they are also in the online version of it too. So that is one nice thing, is whatever you find in the code book is in the online version, including their graphics. Air sealing, that is probably one of the bigger areas that some of the performance has changed rather dramatically in those code cycles, is looking at air sealing and air infiltration. And noting with this, we need to make sure that the air sealing holds up over time. These buildings are going to heat up, they're going to cool down, they're going to expand, contract, and so making sure that we're providing for that. As far as the air sealing itself, how many of you out here have heard, particularly in the residential side, I need my house to breathe. I don't want to seal it up too tight. It's got to breathe. The problem is that breathing, quote unquote, or leaking, occurs and changes based on wind direction and speed and what Mother Nature is going to throw at us. I don't know about you, but I like to breathe all the time, not just when the weather is good or bad. So that's one of those that being cognizant of air sealing and air tightness of our envelope. Because along with this, anytime we leak air, we're probably leaking pollutants, and more importantly, we're leaking humidity, either into or out of this building. And if you're leaking humidity into a building where it's not supposed to be, what are we going to get? Mold. So, equipment efficiency, again, we talk about, these are slight improvements. We've now moved minimum efficiencies from 78 all the way up to 80%. So, hold on to your hats. Boilers, doing away with continuous pilots. Some of these you end up, is the code driving technology, or does the market end up driving the code eventually? Continuous burning pilots on small boilers. I think most boiler manufacturers have gotten away from the continuous pilots anyway. And also noting that hot water boilers, these small ones, you now have to do outdoor temperature resets for that. Unless the tankless hot water heating is going on with them. Yes?
Is that first paragraph referring to no LED pilot light, or are you talking about a gas pilot flame?
This is a gas pilot flame. No. Heat rejection. Not sure how many systems this would necessarily apply to, but noting that when you're using cooling towers to reject heat for heat pumps, some additional controls for the bypass valves and circulating pumps for that. Again, with heat pump applications, try to optimize that and reduce the energy consumption of the system when it's not needed. VFDs, these keep getting cheaper and cheaper. And so this makes it more and more cost effective in lower and smaller systems. So it used to be upwards of between 5 and 10 horse that require VFDs. It's now down to 2 horse and larger. Now there is a provision in the code for if you have DDC systems or direct digital control systems that may allow you to use some of the smaller pumps without VFDs, but they have specific requirements in the code for that. But in general, it's 2 horse and larger. You now have to have VFDs. Heating and air conditioning turn down for HVAC systems, for your variable air systems. Used to be a 30% minimum airflow. We've now reduced that down to 20. And as you can see in the orange triangle there, where you're in the cooling and reheat mode, you are now moving more air than you need. You're cooling it off to get the humidity out, and then you're reheating it back up so you don't end up with a very uncomfortable room. So this is really saying the way to avoid that extra energy between moving the air, heating it, and cooling it is move less air. So they're continuing to drive this down. As you can see, the triangle where we're spending money without providing much benefit is getting much smaller over time.
I have a question about
Yes.
that. So generally, my understanding is the turn down of 30% is related to the minimum capacity of the VFD. And so how do you get a fan to slow down 80% of its rated speed if the VFD only wants to go down to 30%?
Yeah, this is dealing particularly with variable air volume systems. These tend to be larger systems. And so while any box may turn down to 20%, the system as a whole may not necessarily be operating down in this one. This is a particular zone that may be. Now there may be some physical limitations in there, and so that would be something to discuss with code officials as far as, is there something where, because I realize that there is a minimum fan speed way back here at the air handler. Now if all of your zones have turned down to that, then you may begin to look and say, well, do I even need to operate the system at all? Or can I turn the fan off because no zone actually needs it? So there may be some additional programming that may be beneficial in here. So, yes.
Does this apply when you have demand control ventilation?
Yes, demand control ventilation is independent of variable air turn down system. Now the demand control ventilation may actually ramp this up because you need more than the minimum. But this is really saying, what is the minimum the system should be capable of getting to, or should the particular zone be capable of getting to? So there may be individual cases where you'll end up being up here above the minimum area. Parallel flow, the code added a new section for this for parallel flow fan powered VAV boxes. And I think from the feedback that we've gotten, this is kind of how the system has been programmed before, as far as the operation of the fan. So this is more, the code is catching up with what people have figured out. This is a good way to program it. The code now says that's a good way to program it, and you should do it that way. Ventilation controls, they're now mandatory. And they also provide specific applications as far as how do you know if where these are required. So this is the areas that they are now required. This used to be, I believe, prescriptive in the 2015, and they've now moved it to mandatory. So it does not matter whether you're going performance or prescriptive, you now have to have these controls in place. Obviously, demand controlled ventilation. Enclosed parking garages is another common question we get asked about. Ventilation, air heating, energy recovery, kitchens. Kitchens is a big opportunity out there. And obviously guest rooms. And shut-off dampers being, we now need low leak dampers for most outside air dampers now. So. Ventilation, this is providing some further guidance as far as temperature limits on this ventilation air. And again, if we're trying to cool, we don't want to heat that ventilation air more than we absolutely need to. Energy recovery, this is one area where the code actually gave relaxed a touch from 15 to 18. For 2015, if you had ventilation systems operating over 8,000 hours per year, your minimum ventilation, or your minimum airflow before you had to do energy recovery was 0. So if you have a small 10 CFM fan, you now have to do energy recovery on that in the old code. They've now relaxed that a little bit and provided some, you can have some minimum exhaust fans without triggering having to do energy recovery on those. So, not that they gave you a lot of room, but at least they gave you something. This is something that's on the new side is now for automatic controls. Anytime you get over 50 guest rooms for a hotel or motel, you now have to do automatic heating and air conditioning controls. This can be either done via these captive key card systems, which, how many of you have stayed at a hotel or motel that have these? Okay. Each time I'll see a few more hands raised. So we are seeing this becoming done more frequently, or this can be done via occupancy sensors in the hotel management software. So there are a couple of ways to do this, but once you're over 50 guest rooms, you need to have this HVAC controls. So, with that, let's go ahead and take a 10-minute break. All right, a couple of things that came up during the break, good points. One is our website does provide several good resources for you all. We do provide links both directly to the International Energy Conservation Codes, the Illinois amendments to the Energy Conservation Code, as well as the City of Chicago's Energy Code. For those of you who did get some of the books today, for the 2018, there are a couple of errata that have been published since these books were printed that are found on the International Code Council's webpage. There's about, I think, 3 or 4 little typos that they have found that they have corrected in the next printing that they're doing. As far as certificates for today's session, those will be emailed out to you probably sometime early next week. So did want to cover those points. At the present time, there is no official publication of the amendments for the 2018 for Illinois yet. And part of that is because it's still going through the Joint Committee on Administrative Rules process. So once they've finished that, then they will publish it. And that will go live on our website as well. So you can find the links to that. So we're anticipating with the code becoming in force around March 1st, we would anticipate that JCAR will finalize all the amendments sometime either late January or early of February. As far as pressure drop adjustment, they've done some additional additions to this. And something that we do find is through the code making process, sometimes it takes them a couple of code cycles before they get it to really say what they're intending to say. They will put something in the code, and then people will try to implement it, and then they'll go back and say, well, wait, that wasn't exactly what I meant. So they'll try to rephrase that. And that's a lot of what we are now seeing more and more in the code is they're now settling down as far as the actual code itself and trying to make it more usable. So, and this is one of those areas where they had noted that there is an adjustment for each airstream, where before that was not called out specifically. Motor nameplates, these are things that should be on the drawings. However, they do exempt fractional horsepower motors that don't have to be in the drawings anymore. Yes?
Isn't there a requirement though that now fractional horsepower motors have to meet a certain efficiency requirement?
There is motor efficiency requirements. However, with this, it's no longer the nameplates of small, anything that is 1 horse and larger, that must be on the prints. As far as the actual nameplate, and here are the operating criteria.
But how do you confirm compliance if they don't list it?
Efficiency, I think we talk a little bit more about this that I'm trying to recall. Let me, if we don't cover that, let me come back to that. Heat rejection, fan controls, noting there's a specific requirement as far as how to do that now. Here noting the leaving fluid or condensing temperature and pressure. So again, more and more VFDs, but providing more guidance as far as how do you get the controls right. And trying to standardize things so you don't end up with 8 different controls contractors programming things 8 totally different operating ways, and trying to get a little better as far as standardizing best practices. Refrigeration equipment, providing more efficiency guidance on this for some of these areas. This is one that it's a little unusual for this to occur in the codes, but this is a delayed start or a delayed implementation standard. So for walk-ins, setting maximum energy consumption for these. Now this begins January 1st of 2020. Anticipated the reason why was they wanted to provide the manufacturers some time to actually develop these. Now being that this is a national code, I'm sure that the walk-in refrigeration manufacturers were part of the table and part of the discussion to say, what can you do, what can't you do? But providing that, so with this code book was originally printed, let's see here, I want to say August of 2017. So at that time, they had about 2 years to implement. So for us, being a delayed implementer, where we are going to start the 2018, March 1 of 2019, this is going to come in just 9 months later. So I think that's the only part in the code that's actually a delayed implementation part. So HVAC, again, going back to we need to seal our ductwork. And again, this has moved from prescriptive to mandatory. We now need to make sure we seal our ductwork and insulate our pipes. So as far as service hot water heating, there was some efficiency exceptions for if you're using, it used to say solar to provide your hot water heating. It now changed to on-site renewables because there are other renewables out there other than solar. So again, allowing a little more flexibility as far as choice and options for this. Heat traps, this has been common in water heaters for some time now, but they've now added it to hot water storage tanks because they both provide a very similar function. Pool covers, this one they continue to push the envelope on. Pools are now requiring pool covers unless you have at least 75% site recovered energy going towards that pool. So that continues to move forward. How many of you are seeing pool covers going in yet? Not really. So that's unfortunate because pool covers, when implemented well, can provide some good savings without a lot of effort, particularly for all the evaporation that occurs for indoor pools. Service hot water commissioning, this is one area where the code has changed, where they have removed a requirement. So commissioning is no longer required on these systems directly in this section. For residential, now this is residential occupancies in a commercial building. So again, going back to our earlier information about you have commercial buildings and residential buildings, and then you have commercial occupancies and residential occupancies, where the building is looking at the shell of the building. So here noting that residential lighting, you can't use the residential provisions unless you're in multifamily, which is your residential occupancy. All others that are not multifamily buildings use the commercial provisions. this is a new compliance opportunity, is rather than doing this lighting controls on a whole building basis, going into more of individual luminaire controls. So instead of having centralized lighting control systems, you can now have the onboard luminaire level. Now, in order to qualify as luminaire level lighting controls, say that 3 times fast, not only it has to be able to do occupancy sensor, ambient light or daylight harvesting, as well as wireless zoning and reprogramming capabilities. So there's a fair bit of capabilities that are required. But as we'll touch on a little bit, as far as the tighter occupancy sensor zoning requirements, and with the technology getting cheaper, we are now starting to see some of this implemented in some of the projects that we've been working on. With occupancy sensors, they have now added a couple of new or a couple of additional places. The big one is open office areas. Warehouses, they have clarified that they mean the storage area of the warehouse and not just the entire building, but in the storage areas. So, with LEDs being a little more forgiving as far as how frequently you can turn them on and off, occupancy sensor time delays are decreasing. It used to be 30 minutes. We are now going down to 20 minutes, starting with the 2018 code version. Daylight harvesting controls or daylight responsive. I like to begin with the exception here, because this simplifies your life if you can use this exception. And what it allows for is if you can decrease the amount of connected lighting load by 40% of the weighted average of the daylit zone. So in this case, if half of my building is in the daylit zone and I reduce my total connected lighting power by at least 20%, I don't have to do daylight harvesting controls. Because if I take, it's 40% of the weighted area of the building. So this is definitely one of those where if you can fall under this exception, it'll make your life a lot easier. Because if I don't have to buy the controls, I don't have to install the controls, and I don't have to commission the controls. Any ideas why they came up with 40% here? How much do we think daylight harvesting controls might save? About 40%. So, another question that we've gotten as far as, well, can I do manual daylighting controls? You know, the light switch on the wall, does that count? No. Daylight responsive controls have to be automatic. The manual light switch on the wall does not count as your daylight controls. So, rooftop monitors provided a little further guidance as far as how to show the rooftop monitors and calculate that. As you recall earlier, when you have a skylight, it goes in both directions from the skylight. Rooftop monitors, it's only from the monitor back. It doesn't go forward at all. Just a reminder of how those look when they show up on the prints.
Excuse me, I have a question.
Yes.
Recently I've been dealing with IPH for natatoriums.
I'm sorry.
For sorry. And this is really more for indoor things. And their requirements are completely archaic. They don't know anything about the energy codes. Is there any way that at the state level, you can tell IEPH to start following the energy codes? Because they make us take out dimming and daylight responsive controls out of pools.
Interesting. That is the first thing that's been brought up.
It drives me crazy.
Well, and yeah, that's, I'll have to make sure I bring that forward as far
I
as,
tried to explain it to them, and the people there, they don't know lighting, they don't know the energy code,
yeah.
they don't know what they're looking at.
Okay.
They know lumens and watts,
Mhm.
and that's it.
And make sure you use at least 3 watts per square foot to light that pool.
It's ridiculous.
With LED, we want to make sure they can see. So, yeah, if you can send us some contacts over there, that would be useful, and perhaps that would be beneficial for some additional training sessions too.
For all buildings. Basically, they told me, well, why dim it? Why don't you just design it to what it needs to be? It's just trying to explain it to somebody that has no idea. You know, I might as well explain it to my 3-year-old.
Sure. Yeah. I take it they're asking why where the incandescent went too. So, yeah, we are continuing to offer further additional training sessions, and so if you do identify there are certain pockets of people out there that could benefit from that, that is something else that we try to target for our online training modules, is we try to write them for people who this is their first encounter with the code. You know.
But this is the Illinois Department of Public Health.
Understood. Yeah. And they have a definite safety focus, and yes, there's definitely a big learning curve. As far as lighting controls for sleeping units, I'm not sure how frequently we've seen this, but captive keys can no longer use that. I think, yeah, it's been more going towards those key card type approach. Exterior lighting controls, it used to be you had photocells and you had timers. There is now additional requirements that you now have to have both. Now this could be as one system, or it could be 2 controls in series to do your time control as well as photocell or daylight shutoff controls. So they also note that decorative lighting, so this is facade lighting, as well as landscape lighting. So this is not your parking lots or building security lighting, but that has to be turned off during non-business hours. Now they do give you a 1 hour after closing and 1 hour before opening that you can't have them on. And also they require lighting setbacks of 30% of the connected watts minimum. Now that could be, you turn the whole, could be turned 30% off. This could be done through dimming. This could be done through occupancy sensors. We don't see too much in the way of occupancy sensors for outdoor lighting yet. So there is an exception, again, since we're in the commercial section, when we are looking at dwelling units in commercial buildings, that exterior lighting is not included as part of this. Track lighting, we've now reduced our connected load for load calculations from 30 watts down to 8. Now this change is another one where the 90.1 still uses the old 30 watts per linear foot of track. So that's another one where the IECC and 90.1 differs. IECC looked at that and said, if you put 30 watts per foot of LED, that's going to be one bright space. So realizing that 8 watts for load calculation purposes, or the actual fixture wattage if it's higher, makes more sense. Lighting power, we continue to see, fixtures keep getting more and more efficient, so this continues to fall little by little. Offices, you can see just a modest reduction, and most areas were just a modest reduction. The one exception to that we will call out is libraries. For any of you who deal in libraries, they saw a drastic reduction of a third. And part of that is likely because if you think of a modern library, it's starting to look more and more like an office and less of just stacks and stacks and stacks and stacks of books, and that's it. So I think that's probably why this has seen a change. Exterior lighting, as far as what can you exclude from lighting calculations, as far as how many connected watts do you have on your lighting system. For exterior, they have now added this approved lighting. If we think back, approved means acceptable to who? Code official. So that's where it's just for the code official if you need those excluded. Obviously, emergency lighting, exit signs, light our national flag, that's fine. And again, going back to that dwelling units, we're going to go ahead and exclude that. That's your balcony light. Similar to interior lighting, we've seen exterior drop. This has been rather dramatic, going down 30% from 2015 to 2018. And I will call out, this is one of the tables in there that I know there is an errata in the code book. They did make some typos when making the book, and in some areas it said instead of 0.2 watts, they put 0.02 watts. So really, really low power there. So. Gas lighting, I'm not sure, you probably don't see too much of this, but occasionally some decorative gas lighting. You cannot have continuous burning pilot lights for these. I'm not sure that I've seen a gas light that has a pilot light additionally. So. Here, going back to our transformers and motor efficiencies, these have now increased. Dry type transformers, this is one that unfortunately efficiencies are very difficult to find, particularly right on the transformers, because they normally don't seem to say right on the side of them what they are. So you have to actually go look for it. But you can end up with 2 transformers that look identical, but they have very different energy efficiency. The new minimum standard is DOE 2016 for the transformers. It used to be, they had TP1, and that's now been superseded by DOE 2016. And for motors, they now require NEMA premium motors. That used to be the high efficiency stuff. Now it's the minimum efficiency. And now we're just beginning to see come to market these new hybrid motors, which is a combination of induction and permanent magnet motors. And as you can see, they look very different from a regular motor. So it's kind of easy to tell when one of these is involved. But transformers, that's a tough one. Sumi had mentioned earlier about some of these additional performance measures that can be done. One of them is the enhanced envelope. So this is specifically 15% better than the code required. So if you have 15% extra insulation, that will qualify you under this one. The other one is reduced infiltration. Now this is one where it is actually based on a building pressure test. Has anyone out there done a commercial building pressure test yet? One. That is the first one I've actually seen, or two. This is highly unusual, unfortunately. The code requires for building envelope for commercial is you can either pressure test the envelope or use one of, I believe it's 13 items on a list. Well, unfortunately, you can use the right stuff and not install it correctly. So this is great. But yeah, so if you actually test your envelope and end up with a low leakage rate, that can allow you to qualify under this. They do also provide the little caveat for large buildings that you may test them in sections, but you have to test at least 25% of the floor area. Electric vehicles, the code now calls out this is not considered a building load. I don't think that's a surprise, but it is now actually stated that for any of your performance measures, you don't have to include your electric vehicle in the calculation, because obviously the base model does not have it. Renewable energy, if you're going through the performance, they now cap your on-site renewables at 5%. You can install more than that, but your performance model, you can only put 5% in the model. And that's partially to prevent things such as this. A lovely greenhouse covered in solar. I'm not sure how the sunlight is supposed to reach the plants that are inside the greenhouse.
Artificial light.
Driven off our solar. So you end up with some silly things that you look at and you say, really, did that help? So they're saying, we're gonna allow you a 5% credit, but anything beyond that, we're not going to put that in the model. So you can still have a net zero home, but so it also allows code officials to request the documentation of how did you arrive at your number. You know, if you're going to claim a credit, you know, let's see how you ended up with that. Operations and maintenance manuals are now required to be provided under the code to the building owner, and in particular, it talks in there about the actual, there needs to be a listing of these are the O&M things that need to be done. You know, you need to change belts on this, you need to oil these motors, you need to do X, Y, and Z. And that listing needs to tell them where in these books to go find the information about what that actually means. So it could be you need to change belts on the air handler, see, you know, such and such book, section, you know, section Z. And again, part of this is we are building these buildings and we want them to last. And if you have no ability to maintain the building, because we realize that you know, a building mechanic got all of 15 minutes of training on this, you know, 100,000 square foot building, because we did require training to be provided. But they have to be able to maintain that building, and in particular, when that building mechanic leaves and a new one comes in, they're going to need to be able to pick up and understand how to maintain this building. So we end up with buildings that can last 50, 75, and 100 years. Commissioning report. part of this is you have to do functional performance testing for commissioning, and these reports must be provided to the code official as part of the documentation. So,
You're saying that this is a have to?
yes. Yep, this is part of the requirements of the code now. So, need to,
All of our clients have to hire a third-party functional tester for all of their.
it doesn't necessarily have to be third party, but someone has to commission the equipment, and they have to provide that documentation that it has. So it could be the lighting manufacturer, as part of their installation, is come out and do the commissioning on the systems. But someone needs to make sure that the systems actually work as designed and provide that documentation to you. So something I will call out in these slides, you'll notice up in the corner, we actually provide the reference back to what the specific code section is, so you can read the more in-depth, the actual language of it. Alterations, this gets into, most of what we deal in is renovations and alterations. So this is one where if you have a change in space conditioning, such as, I've had and this will be a residential example, but I have a garage that was unconditioned before, and now I'm going to alter it and turn it into a bedroom. So I'm going from non-conditioned or low energy building to fully conditioned. So that's where this is change in space conditioning is going from low energy or non-conditioned to conditioned. That's not necessarily, I'm changing it from an office to a library. So, but this allows for, you can use performance to demonstrate compliance with the code. And they provide you can go 10% over the code in this example. So what this allows you for is you may have built a building, going back to our unheated warehouse example earlier, it may have been such that they built the warehouse as a non-conditioned space, but they built it to the energy code at that time. Well, the new code came out, and now they're going to condition it, and so this extra 10% adder says, you tried, you were close, we're going to let it pass. So you're allowed you cannot exceed 110% of the path chosen, which is 10% over the code. Excess fenestration, I'm sure we've all seen these buildings where it used to be factories and now we've turned them into studio apartments. But for buildings, because the code states, here's your maximum fenestration percentage. There's an exception that allows for areas that already have excess fenestration. So in the event that you want to replace a window that's existing, you are allowed to do that such that the new window meets the current code. You don't have to brick up these windows in order to comply. So it's kind of the end of commercial. Switch over to residential. Other questions on commercial side so far? None? All right. Now this one, it's not a change, but we like to call out some of these highlights in the admin, noting what should be on the construction documents. So this is a listing they provide of the items that need to be on the construction documents. So this is for residential buildings. And in particular, not surprisingly, a depiction of the thermal envelope. So what is your equipment sizing, efficiencies, things like that nature. Air sealing details, that could be one that's a little bit less common, but should be in there. So how are you going to seal this building up? Types of inspections. See, I've actually used the old framing and rough-in definition in there. But footing and foundations, our building envelope, plumbing, mechanical, and our final. And the book, even the code calls out what we're actually looking for in each of these, whether it's insulation and its location and installation method. Mechanical is equipment efficiencies and such like that. So here, touching on those, what is it that we're having to look for? Obviously, footing and insulation, we're looking at our insulation and our thickness. Did you actually install what you said you would put in there? I know that never happens that they specify 2-inch insulation and 1.5 inches goes on. Framing and rough-in, again, looking at our insulation, our windows, and our air leakage controls. Our air barrier should be in here at this point, because that's part of our thermal envelope, is that air barrier. Plumbing, obviously insulation, any controls, so if you do have a recirculation system on the service hot water, controls in place for that. Our mechanical equipment size, controls, again, duct insulation, R values, so on and so forth. Programmable thermostats are required, which I'm sure everyone programs. Whole house ventilation. This leaves an interesting question. How many of you out there frequently see exhaust-only ventilation used for whole house? So, several people. So I'm going to just have an exhaust fan and rely on leaks to bring the humidity and dust into my house. That is something that we definitely encourage. Balanced ventilation, such that it's going to operate well. Plus, if I bring the air in on my terms, I can filter it before it gets into the house. But just noting, is the whole house ventilation system as designed? Is it there? Then final, predominantly looking at high efficiency lighting. Residential certificate. This is something that needs to be provided. Commonly, we will see this located near the electrical panel. It may be on the cover of the electrical panel, listing all of these items. What are the U factors of the windows? How much insulation is in the wall? How much insulation is in the attic? Any duct and envelope leakage tests. So this is giving us what is the baseline of this building. So if I end up where, I have a home where I have a very tight envelope, and then I have problems heating or cooling and come back and do a pressure test again later, I have some baseline to go back to say, did something change here? Or, even better, I go to replace that window. Well, I want to make sure that I put at least as good a one that I had in there before. Those stickers are long gone. This is what that may look like. This is one example of something we've seen used before. And it's very handy. What is all the various R values? How much are we expecting to see? Duct testing, blower doors, if you do duct testing. what is the U factors of these things? So when a window breaks, I make sure I put a good one in there. So kind of all the handy things to know when you go to replace something. Log homes, this has been taken out of the IECC, and it's now a different standard. So thermal envelopes for log homes have to meet this 400 standard, not the IECC thermal envelope. I'm not sure how many, have any of you built any, or had any built in your jurisdiction of log homes? 1, 2, a couple. We don't see that too frequently, but they just pointed to the other standard. Windows, just a nominal increase or nominal improvement on Windows, 0.35 up to 0.32, so a little bit of change. It's a good question. How many of your municipalities require building permits on replacement windows? Several. Of those who do, how many of you have seen problems with meeting this U factor initially when you first started enforcing it? Several? Okay. By far, this is the biggest one that we see a problem with. So if your municipality does not require building permits for replacement windows, we would encourage that to change, because this is where the problem occurs. Probably 90% of the problems that we see is right here on replacement windows. Reduced insulation. So if you have full depth of insulation all the way over the top plate, you can get some benefit and reduce how much the total thickness of your insulation has to be. So I believe here R49, if I recall, can be reduced to R38 if that's extended all the way across the top plate. So again, this is a potential for a thermal bridge right here if you get reduced insulation right there. So they're allowing you to take advantage of, if you eliminate that thermal bridge, you've now created a better performing envelope so that we can reduce our insulation elsewhere. So it's kind of a trade-off there. I'm going to do something better, and I'll trade something else for it. Sunroom insulation, again, this is not new, but wanting to call it out as far as sunrooms, noting that if they are conditioned, then they have some additional, some more lenient thermal envelope requirements for sunrooms if they're thermally isolated from the rest of the building. If they're not, then the envelope requirements apply. And similarly for fenestration, providing a little bit more allowance for fenestration of sunrooms if they're conditioned. So we get a lot of questions about sunrooms. So this is one, does a fireplace count as a heater for determining are we in low energy building or status or not? Because again, if I have low energy building, I don't care about your walls in the sunroom. So noting that fireplaces, they count as a heat source. So
Are you calculating BTUs on a fireplace?
BTUs on a fireplace? Typically, if it's a gas fireplace, mainly
Solid fuel.
solid fuel. Well, depending on what the solid fuel is, it'll depend. But in order to meet low energy requirements, it probably would be how much fuel can you put in it. But as far as low energy, that threshold is so low Basically, if you are going to put a fireplace in, you're over the limit. Pretty much. Because again, it's 3 BTUs per square foot. 3.4 BTUs per square foot. If you put a fireplace in, you're over. For almost any sunroom you look at. Because a fireplace is, even if I have we'll be crazy and say 500 square foot 500 square foot sunroom, 3 BTUs, 1,500 BTUs an hour, plus some. I'll give you 2,000. Any fireplace is going to be over 2,000 BTUs an hour. Unless it doesn't actually have a heating element in it. But solid fuel, you're going to be over 2,000 nameplate on it. Heated garage. Here there is a specific Illinois amendment for heated garages. So, yes, you have to meet the thermal envelope requirement. However, Illinois has an exception for heated garages. While, yes, you do have to design the thermal envelope to meet the requirements, you do not have to include them in your building pressure test. So the garage itself doesn't have to meet the air leakage test. But you have to have all your insulation, you have to have your air barriers, and so on and so forth. So that's one that Illinois did remove that pressure test from it. Roof insulation, this is one where it gets a little strange in the code because residential, they don't have flat roofs in the residential side, at least in the tables, unlike the commercial side. So here, if you have a flat roof in a residential building, have to comply with the residential insulation provisions. That's an R49 on that roof. Flat roof. So that's quite an achievement. However, this is where you may approach your code official and say, if there is something, particularly when you get into renovations, there may be a reason that meeting an R49 could be technically infeasible, whether that's roof curves or other impediments where you say, I've put as much insulation I can with what I have been given. Because that's something that the code calls out in renovations, is you don't have to, the code compliance stops with what you're working on. So if you're working on a roof and doing roof insulation, I can't make you go and raise the parapet walls just to meet the roof insulation because I was touching the roof. Those are two independent things. Now I can say I want the maximum amount of insulation you can get given that parapet wall height. But, so this is a big difference for flat roofs. Is if you're in a residential building, it's R49. Commercial, I think it's R30. So big difference there. Moisture control, and this was something we had touched on earlier. They were relocated to the IRC or IBC a few code cycles back. So that is something that now that we're aware of where that change happened, that's something that I need to keep in mind. This table covers most errors that you will find. R402, 411. This table, it covers air barriers and insulation requirements. Almost every time that we go into a building and find mold, it is because of this table. There was something in this table that was missed. So, that is a very handy table to use. Ductwork testing, This provides clarification. If you're using energy recovery ventilators or heat recovery ventilators, that ductwork is not included, is exempt from the testing requirements for your pressure test, or for your duct leakage test. If you're doing performance for buildings, there's now allowances for ducts that are fully buried in the insulation, and the code provides guidance as far as what that definition, or what the criteria is to meet this definition of buried ducts, as far as where the R value is and how much you need to have. How many of you have seen these drain water recovery systems put in? Couple. And we've not seen a lot of these. If they're used, then they have to make sure they comply with basically a low pressure drop standard, because we don't want this drain water recovery system to then cause a problem on the plumbing side. So I love the concept. I've never had experience to see how well they truly work. I've added some efficiency requirements for HRV and ERV fans. I'm not sure how many units that are out there actually don't meet this standard, because ERVs and HRVs tend to be a higher, that's a more premium product, because most people just go with exhaust fans. Ducts in conditioned space. The code has provided some guidance as far as how do we know if the ductwork is in the conditioned space or not. And this part of that goes back to air leakage testing and that. But it notes that obviously if all your ducts are completely inside the air barrier, you are in the conditioned space by definition. Or if you are, going back to the buried in ceiling insulation, and the air handlers inside the air and thermal barrier, and when you do your duct leakage testing, it comes in at under 1.5. Regular duct testing is 3. And you have full depth insulation above the duct. So again, in this area, we're probably in R49. So you'd have to have a full R49 above the duct. So if you meet all those criteria, then you are considered in the conditioned space. Equipment sizing, this is something that is fairly new to the code, but it's not for 2018. Making sure that we have manual J calculations done. Or other approved heating and cooling calculation. I've seen a couple of different ones out there. What common types of calculators do you guys see? Anything other than manual J or express manual J? Anyone? Yep.
We've got a lot of issues where we have software tools people are using that are using manual J calculations. They're not officially listed on the Acme manual J website because they want to gain those licenses.
Okay.
Allegations of those being accepted because now somebody has to decide.
Oh, that's
the
okay. So Acme does have a listing on software that does.
They do. It's extremely expensive to get your software listed.
Oh, interesting.
Like 7 digits expensive.
Oh, I bet. I'd love to get that myself. But that's an interesting thing as far as how do you handle those where it's it says it's using manual J but it's not officially listed. So I have seen some paper calculators that I found were interesting, and there again I don't know how accurate those are and whether that would be acceptable or not. But again, going back and saying what is going to be approved by the code official. Now ACA does have manual J express sheet that you can use at no cost. But equipment sizing, that is very important, particularly on the air conditioning side. Because, I mean, if I oversize a heater some, I'm not going to face a lot of challenges with that, but if I oversize air conditioning, now I don't have dehumidification, and that's a problem. Not that we want to oversize equipment anyway. Pool covers, this is very similar to commercial. Pool covers, got to have at least 75% of site recovered energy to not require pool covers for heated pools. High efficacy lighting. For residential, this is probably one of the biggest changes for the 2018 code. And that is, not only did we increase from 75% to 90% of the installed luminaires have to be high efficacy. I will make a note, Illinois does have an amendment of what is high efficacy, but basically it's just use LED and you're generally fine. But the big one is low voltage exception is gone. So all those little MR16s count now in the new 2018 code. So again, part of that goes back to why track lighting has changed in its lighting, in its load calculation. Is that low voltage exception going away? Made a big change. Ventilation, if you're going the performance route, the energy for the energy and heat recovery ventilation system or the exhaust fan or however you want to do ventilation, you have to include that in the energy model as far as performance. Used to be that was not part of it. Multifamily, so if you have a lot of multifamilies, they now allow for performance where you can use a single model for units that are identical or nearly identical, same size, same square footage, same exposure, etc. You can now use batch sampling. So you can model, if you've got a large building, you may end up with only 9 models per side, because the two that are next to each other that are basically the same, I only need to run the model once for it. Again, with the performance, because we added our mechanical ventilation in our energy model, the reference model also added that in. So we've made sure to balance the equation, so we've added it for both sides. Energy rating, it's now changed to the IECC 2006 reference. It's now an ICC standard that they're now using as a reference. And again, similar to the commercial side, your electric vehicle does not count as part of your building load. As you saw, the reference has moved from the IECC to an ICC standard. As such, they want to encourage people to use the ICC standard and get a HERS rating. And so with that, the performance for the HERS rating has increased rather dramatically, up almost 10%, or almost 10 points from the 2015 to the 2018. How many of you are seeing HERS ratings being common in your municipality yet? None. Okay. Similarly, since it has its own standard, we'll just go ahead and remove our software listing from the ICC. Alterations. So if you get into residential alterations, fenestration, you're allowed to use a weighted average area to show your compliance. So if you want to have your decorative stained glass window, you may. You just have to make up for it somewhere else. Insulation as part of alterations. So we've got, wood frame wall being re-insulated. What's our required R value? Yes, this is an alteration, and therefore have to put an insulation of at least R3 per inch. Now, so the goal here is I'm trying to meet what our energy code states I need, but there is an exception in there that says if you expose it during construction and you fill the cavity with insulation, if it doesn't meet it and you filled the cavity, that's it. You don't have to modify that wall or fur it out in order to fit the required insulation as long as you have filled it. Because again, what is the best you can do within the constraint that you have? Now, if you want to replace that wall, then go ahead. Then you need to meet the requirements. But just exposing the cavity does not require you to fur it out. So, touch on some of the Illinois amendment proposals. So this is what has been proposed and has actually made it through the process so far. So we do anticipate this is what's going to stick. Residential, we're moving from 5 ACH down to 4. The anticipation is in the next code cycle, so that would be the 2021, they will eliminate this completely and go with the code's 3. So previously the code had moved from 7 to 3, at which point Illinois is like, whoa, okay, that's a little much. So we've gone from 7 to 5, now to 4, and then for 2021 we'll probably go to 3 at that time. And then because air changes per hour is a little bit of it can skew things, particularly when you get into smaller units, because of surface area to volume ratios. And so what they have proposed is adding an alternative air leakage testing for multifamily of 0.25 CFM per square foot of enclosure. So again, this is really getting to the meat and potatoes is I want the envelope to be sealed. And so that's what I'm testing is how sealed is the building envelope, not how much, how many air changes per hour, because that's more of a volumetric is, did I build a good envelope? So they are doing that, adding that. So, and similarly, you can actually do some batch testing of this and sampling. Again, trying to get a little more scientific about this and say, did you do a good job? And do I have a good representative sample of this? Rather than, I'm building a 400 unit building and I have to test 400, I got to do 400 blower doors. That's a bit much. So this does allow for some sampling. Something I'd like to put forward and say, okay, I don't know, how many crawl spaces versus basements do we end up seeing? How many see majority crawl spaces? Okay. Majority basements? Majority slab on grade. Okay. So yeah, this one's a little bit further south. We tend to see a lot more crawl spaces and saying, well, if we go through and use our ventilation system to provide some of that turnover for crawl spaces, that could be a better methodology than just using the heating and air equipment. Because in one of these samples, we ended up 27% of the year with almost no heating or air conditioning going on. So that's a lot of time of the year to have no turnover of crawl space air. So, other questions we've got? Yes? Sealed combustion and combustion rooms, that is an Illinois amendment. They've taken that piece out of the International Energy Conservation Code. They've decided to not use that. You kind of touched on my easy, here's how you get out of it, guys. Just use sealed combustion high efficiency appliances. But yeah, Illinois has decided to take that out in the 2015, and it is proposed to stay out for the 2018. Something I should mention, if you email us questions, which we definitely prefer email versus calling, because first thing that we end up doing is if I get a question, I'm pulling out my code book to find out what exactly does it say. Not what would I like it to say or what do I want it to say, but what does it say? So even if you do call us, I'll probably have to say, we'll take down the information and then have to get back with you so we can pull out the code book and read exactly what it is. But it is very helpful when you send us a question. Let us know if you are in residential or commercial, because sometimes that's not very clear by the question itself. So that is very helpful for a class. Any other questions that we have? Sue's got something.
Thank you. Also, if you have more questions, we'll be here for a little bit more, so you can come to us and ask questions. And I just want to briefly mention the book that you got from outside is called Success with 2015 IECC Illinois. It's only for residential, so just remember. But it gives you a good, information for commercial too, because it has lots of pictures and diagrams for the good envelope design and stuff like that. So for 2018, there'll be a few changes in terms of numbers, but still lots of recommendations and guidelines still valid and very useful. So feel free to use it, and if you have any questions, come and ask them. Thank you very much.